Hello class, you are welcome back. We now look at median. Now the median is a term representing the middle value in any set of data for a variable, okay? When the data values have been ordered or ranked from either the lowest to the highest or the highest to the lowest. So the median divides your data set into two equal parts. And for the median, extreme values do not affect the value. So if you recall, when the mean, in the case where you have values that are quite apart from the general population, it distorts the mean a bit. But for the median, since it's simply looking at position and looking at the number within the middle, even if you have extreme values or either at the high level or the low level, the middle value just remains there. So for example, if you have some ages in your class, for example, majority of you lie between 20 and 30, and about 2 or 3 people lie between 40 and 50. Whatever value falls within the middle of, when I line up all your ages from the minimum age to the highest age, and I choose the middle age, whether there's someone age 60 or 70, or there's someone age 15, it doesn't affect the middle number. It's simply a position, all right? And when you're calculating the median for a very large number of values, you may not be able to quickly identify the middle value. So if you want to determine the middle position, you add 1 to the number of values and divide that sum by 2. So for example, if you have 127 values, plus 1 of that is 128, and 128 divided by 2 is, you have it here, 64. And then you determine that the median is a 64th ranked value. So you look for the 64th value, and that represents your median. For 70 values, for example, you add 1, which is 71, divided by 2 to get 35.5. And at this point, 35.5 means that the median is a value between the 35th and the 36th ranked value. So what you do is take these two numbers, find their mean, that is, sum them and divide by 2, and the value you get becomes your median. Let us now look at an example. You are asked to calculate the median age of a group of employees whose individual ages are 47, 23, 34, 22, and 27. Now you can calculate the median how? By first ranking the values from the lowest to the highest. So when you rank them, you are getting 22, 23, 27, 34, and then 47. Now there are simply 5 values, so it's very easy to identify the mean. The median is the middle value. So if you look at these 5 values, 1, 2, 3, 4, 5, 27 is the number in the middle of these ranked values. So our median is 27. So it means that half of the workers are 27 years old or less, and half of the workers are 27 years old or more. All right. Another example is here. You are asked to calculate the median for the original set of 10 get-ready times from workout problem 1. From our session on mean, we looked at a certain table where we had time until a worker wakes up from bed and gets ready to go to work. So we're repeating the data here, and we want to now find the median of the data set. At this point, we have ranked the data set. So we have the lowest time and then the maximum time. Now you realize that there are 10 of such values. So, and it means that the count of values is even. So to find the median, you would need to know the 2 values that lie in the middle. Once it's an even numbered count, it means that there'll be 2 values in the middle. So you need to find those 2 values, find their mean, and the value you get becomes your median. All right. So given 10 values, 5 and 6 are live in the middle, all right? And the times corresponding to the 5th and the 6th position is 39 and 40. So to find the median, you sum 39 and 40, then 39 plus 40 is 79. 79 divided by 2 is 39.5. So the median for this set of 10 times is 39.5 minutes. So as a way of notation, Let's say we are given n number of data points. How do you find the median? The median is your n plus 1 over 2 ranked value. So you find the total number of counts that there are in your data. You add 1, divide by 2, and that gives you the position of your median. All right. So let's look at a case where we have a very simple or raw data. The following set of data shows the ages in years of some people at a birthday party. Now these values are given. You can see that they are not ranked. So we can do the ranking ourselves. We start from the lowest value, which is 5, and then we arrange them ascending order until we reach the maximum value of 39. Looking at these values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 of these counts. 13 plus 1 is 14, and 14 divided by 2 is 7. So the median is the number in the 7th position. So 1, 2, 3, 4, 5, 6, 7. Exactly. So at this point, our median is 7 years. Now let us try to understand how to find the median for an ungrouped frequency data. So we have a table here where we have some X values, which may represent ages, and these are the frequencies. So number of people who are 8 years old, 2 people who are 10 years old, 8 people are 12 years, and so on. We've seen this data, we saw this data when we're discussing the mean. So for the ungrouped frequency data, once again, to find the mean, you will need to know the total data count, which we have here. Summation of the frequency is 45. You add 1, divide by 2, and 46 divided by 2 is 23. So the median is the number in the 23rd position of your data set. Let's go back. Now, where is the 23rd position? You start summing your frequency. So 1 plus 1 is 2, plus 2 is 4, plus 5 is 9, plus 8 is 17, plus 1 is 18, plus 5 is 23. So our 23rd value lies at this point, and the X value corresponding to this position is 14. Therefore, our median is 14 years. How about the case of a grouped frequency data? So in the case of a grouped frequency data where the actual data points are not available to us, the data available to us are within class intervals, or they are grouped. So we have a table here. This is a group frequency table. We have some class intervals and we have some frequencies provided us. Now to find the median of a group frequency data, this is the formula you need. L subscript M plus summation of F over 2 minus F subscript M minus 1 all over FM, all right? That should have written the formula properly. So you'll soon understand these features and how they play out in your formula. All right. So for group frequency data, first of all, you need to know your median class. How do you know the median class? The total of our frequency is 60. So 60 plus 1 is 61. 61 divided by 2 is 30.5. So let us start. 3 plus 8 is 11. 11 plus 21 is 32. So 31.5. 30.5 is in this row, all right? And the corresponding class interval is 70 to 79. So our median class that we are going to work with is 70 to 79. Now, once again, as I mentioned, the value here, let's look at it. We have the formula here, so we want to understand the components of the formula. Now, L subscript M is the lower boundary of the median class. Take notes, our median class that we are working with is 70 to 79 from our data. So to know the lower boundary of the median class, we go back to the table. The lower boundary of this interval is 69. So that is what we have here. Now F subscript M minus 1 is the sum of the frequencies before the median class. So you're summing all of the frequencies that exist before your median class. We are here now. This is the median class. So the frequencies before it are 8 and 11, all right? 8 and 3, and 8 plus 3 equals 11. So we have f subscript m minus 1 being equal to 11. Now, small f subscript m is the frequency of the median class. Now we have a median class here, the frequency is 21. So we have it there. Now C subscript M, this is subscript, it's not well written, is equal to, is a class size of the median class. So if you take the median class, considering the class boundaries, the class size is 10. So we have it provided, all right? So in writing out actually the formula, this place should be small f subscript M, and then this point should be C subscript M, all right? So once you have this, what you do is you're fixing all these values in the formula. Some of them have already been fixed at this point. So you're fixing the remaining ones, and then you do your simplification and perform your algebra to get a final answer of 78.5. So in this case, our median is 78.5. Now let's look at the third measure of central tendency, which is the mode. Now, when it comes to mode, we are looking at the term the most or the majority. If I come to your class and I take the ages of students in the class, and it happens that out of 80 students, there are all manner of ages there, but people who are age 25 are the majority in the class. In that case, the mode of ages in your class is 25, right? So the value in a set of data for a variable that appears the most frequently is your mode. So for example, we may have the most common disease tested for in a lab. Some data may not have a mode, others may have more than one mode. So if it happens that in your class, I said that there are a number of people who are 25 years old, and it happens that those who are 24 years old is the same count. It means we have two modes of ages in your class. There can be cases where there's all values are just the same count. No number stands out as being the majority. In that case, that data set doesn't have any mode at all. Now let us look at this data. For a simple or raw data, for example, the following set of data shows the ages of some people at a birthday party. Once again, if you look at this data, best you should rank them. But if you can eyeball and see, there's 6 is 1, 2, 3, 4, 5. There are 5 ages that are 6 years old. 7 has a repetition of 1, 2, 3. So 6 is still reigning. And every other number appears just once. So at this point, the mode is 6 because 6 is the most frequently occurring age. In the case of an ungrouped frequency data, you have a list of points here which represent our ages and their frequencies. Now, the focus is to look at the frequencies. If you look at the frequency, the highest number here is 8, which means that the mode of these values is 12, all right? Because 12 is the age that has the most occurring. 12 is the age that happens the most because its frequency is the highest. Okay. So we are saying that in reference to the ungrouped frequency table above, the mode is 12 years. Now let us look at the case of the grouped frequency data, where the actual data points are not available to us. We have here the class intervals, the class boundaries, the frequencies, and this is the column of cumulative frequencies. What happens here is that you are summing up the frequencies at every point in time that you are. So for the first row, the frequency is 3, and then cumulative frequencies is still 3 because there are no values preceding it. Now for the second row, frequency is 8. So the cumulative frequency is 3 plus 8, and that gives us 11. Third, we have 3 plus 8 plus 21, giving us 32. We have 3 plus 8 plus 21 plus 17, giving us 49. So the cumulative frequency is simply summing up all the frequencies up until that point that you are. And the summation of frequency here is 60. It means we are dealing with 60 data values. Now, how do you find the mode in a case of a group frequency data? The mode, first of all, we need to find the modal class. If you look at the frequencies, the highest frequency is 21. So the modal class is 70 to 79. Now, this is the formula for finding the mode for a group frequency data. The small l here represents the lower class boundary of the modal class, all right? And then D1 here represents the difference between the frequency of the modal class and the frequency of the class just preceding it. So let's find L first, lower class boundary of the modal class. Modal class is 70, lower class boundary is 69.5. We have it written here. Now, D1, difference between the frequency of the modal class and the frequency of the class preceding it, just the class preceding it. Now, the frequency of the modal class is 21. The class preceding it, which is 60 to 69, the frequency is 8. So 21 minus 8 gives you 13, all right? So D1 is 13. Now, D2 is the difference between the frequency of the modal class and the frequency of the class after it. So when we come back, D2 here, frequency modal class is this, modal class after it is this. So the difference between their frequencies is 21 minus 17, which gives us 4. Now C is the class size of the modal class. Our modal class is here. If we come to 8 class boundaries, the difference is 10. Therefore, our class size is 10, right? So C equals to 10. So at this point, once you figured out the corresponding values to these variables, you fix them into your formula, and then with the help of your calculator, you can find out the modal value. These values seem to be weights, okay? So the modal values, the final modal value of the weight is 77.15 kilograms. To end the session of the central tendency measures, let us look briefly at the concept of quartiles, all right? So quartiles are 3 values that split a set of data ranked, a set of ranked data values for a variable into 4 equal parts. So we have the first quartile, which is Q1. We have Q2, the second quartile, and then Q3. Now Q1 is a value such that 25% of the ranked data values are smaller, and then 75% are larger. Q2, also known as a median, it simply splits our ranked data values into 2 equal parts. And then Q3 is the value such that 75% of the ranked data values are smaller and 25% are larger. So quartiles help us summarize large data sets by allowing you to find the 25th, 50th, and the 70th percentile, 75th percentile. So for example, if you scored in the 3rd quartile of a test, it means that your score was in the top 25% of all scores, right? So it means that you did better than 75% of the people in your class. But if you did exceptionally well and you learned that your score was reported as the 99th percentile, you know your score was in the top 1% of all scores, all right? So how do you find the quartiles? Q1 is, to find Q1, you should know the N, that is the number of data values we are dealing with, N plus 1 over 4. Therefore, the first quartile is the N plus 1 over 4th ranked value. And then this is how you find for the remaining ones, right? So to end, let me give a brief illustration of the quartiles, and then we can end the session. So let's take, we have these data points, all right, 2, All right. So we have 10 values here. If you want to find the first quartile, which is Q1, it's giving us n plus 1 over 4. So we are looking for this position. There are 10, n is equals to 10 because there are 10 data values here. So we have 10 plus 1 over 4, which is 11 over 4. And that is 4. 11 divided by 4 is 2.75. All right. So you're looking for the position that is falls with the 2.75 position. This is the first position, second position. Okay. So we will have to work furthermore to find out what to read, because it's the third position, to find out what really will be our first quartile. We can look more into this and then we can discuss when we meet in class. All the best and see you in the next session.